ever stood near the coast on a hot summer afternoon, you may have had this happen to you. The air is still for part of the day. The sun is beating down. Pavement, rooftops, sand and soil, they're all heating up. Then sometime in the afternoon, you finally get a respite. A breeze begins to move in from the water. I remember this clearly from my time as a TV meteorologist in Corpus Christi, Texas, back in the 1990s. Inland cities across that coast could well be over 100 degrees Fahrenheit during the day. Places like Falfurrias, Beeville, or Alice could be brutally hot. But right along the coast, near the bay, Corpus Christi might be 10 degrees cooler. And the big reason for that was the sea breeze. That moving air made the city more livable. It helped clear out stagnant air, and on many afternoons, it helped spark showers and thunderstorms that cooled the surface even more. Today we're going to talk about this weather pattern, why it forms, and look at new research suggesting that warming ocean waters due to human-induced climate change may be weakening this in some of the world's major coastal cities. Welcome back to the podcast. I'm Dr. Mack, and this is the Climate Translation. To start out this episode, let's discuss what a land sea breeze is. It's something I often discuss in the classroom, and it can be confusing. The breeze is not just air moving in from the ocean. It's driven by one of the most basic ideas in atmospheric science, how air responds to heating. During the day, land and water do not heat up at the same rate. Land heats up more quickly. It absorbs the energy from the sun, and its temperature rises rapidly. That's why pavement, sand, and soil can feel so hot by the middle of the day. Water behaves differently. It takes much more energy to raise the temperature of water, and it also mixes vertically. So while land is heating up rapidly, the ocean or a large lake can stay relatively cooler. That difference in temperature is where everything starts. In this podcast, we've discussed the idea that warm air tends to rise and cool air tends to sink. As the land heats up, the air above it warms as well, and that air expands, becomes less dense, and begins to rise. When air rises, it lowers the pressure at the surface. Over the water, the opposite is happening. The air is relatively cooler when compared to the land. Cooler air is denser, so it tends to sink. That creates a relatively higher pressure compared to the land. And this is where I usually pause in class and give a simple example to help everybody keep it straight. If you press your hand down on a desk, for instance, you're applying pressure. You are pushing down on the surface. That's like high pressure in the atmosphere. Air is descending and pushing down towards the ground. Now lift your hand. You're releasing that pressure. Your hand's moving up. You can think of that as low pressure. Air is rising away from the surface. So during the day, over the land, we're essentially lifting the hand. The air is rising and a small area of low pressure develops at the surface. Over the water, the air is sinking, like when you press your hand down. These differences cause wind because air moves from high pressure to low pressure. Thus, air begins to flow from the water, high pressure, towards the land, low pressure. That movement of air is called a sea breeze. We see the opposite at night. As the sun sets, the land cools quicker than the ocean, which retains its heat. Now, the air is cooler and denser and sinking over the land, creating high pressure. And it's warmer, less dense, and rising over the ocean. That's low pressure. That leads to a reverse flow of wind off the shore, where it's high pressure, and out to sea or the lake as the night progresses, where it has more low pressure. The wind is a natural reaction as the atmosphere tries to restore the imbalance and even things out. The stronger the difference in temperature between the land and the water, the stronger the sea and land breezes. Now, at this point, it might be tempting to think of the land-sea breeze as just a nice feature of coastal weather, something that makes it nice and comfortable in the afternoon. But it's doing much more than that. In many coastal areas, especially cities, this breeze is part of what makes those places livable. We've talked on this podcast about urban heat islands and how cities tend to run warmer than the surrounding countryside because of things like concrete, asphalt, and reduced vegetation. Those surfaces absorb heat during the day and release it slowly, especially into the evening. So even in places near the water where you might expect things to stay cooler, cities can still build up a lot of heat. And a sea breeze helps offset that. It brings in relatively cooler air from over the water and pushes out some of that built-up heat. It creates movement in the atmosphere, and that prevents the air from becoming stagnant. And movement's important because when air sits still, things tend to build up. Pollution is one example. In many urban areas, cars, industry, and other sources release pollutants into the air throughout the day. Without airflow, those pollutants can accumulate near the surface. I remember very well ozone action days when I was in Corpus Christi. These were days of stagnant air when we asked residents to reduce their driving or lawn mowing, for instance, anything that might use gasoline products and produce exhaust that could exacerbate the issue. The sea breeze acts like a natural ventilation system. It helps mix the air and move some of those pollutants away from where people are living and breathing. And the same idea applies to things like pollen. During the spring, pollen levels can build up quickly, especially on warm, calm days. Without wind to move the air around, concentrations can stay high in different places. Even smoke behaves this way. We've seen this in recent years, especially in the northeast United States, where wildfire smoke from Canada moved into major cities. When the atmosphere is stagnant, that smoke can linger, sometimes for days. Airflow helps clear that out. It doesn't eliminate it, but it does reduce how long it stays concentrated in specific areas. And then, of course, there's moisture. That onshore flow doesn't just bring cooler air, it often brings more humid air. And as that air moves inland and continues to rise over the already heated land surface, it can help form clouds and, in many cases, trigger afternoon showers and thunderstorms. You've probably seen this if you've lived near a coast or a large lake. A line of clouds forms inland during the afternoon. Storms develop roughly in the same area day after day. It's the sea breeze acting as a boundary, lifting air, adding moisture, and helping to get things started. So you can start to see how vital this phenomenon is, especially to our coastal cities and communities. What's troubling is that recent research is beginning to point to a breakdown in this effect as the oceans warm due to climate change. So let's loop back to the difference between land surface temperatures and that of the ocean. That difference, what we call the gradient in atmospheric science, is key. The stronger the difference between the high and low pressures, the stronger the wind that develops. So what happens when that difference begins to shrink? Well, that's exactly what some research is beginning to look at. Yunting Xiao is a researcher at the Institute of Surface Earth System Science in the School of Earth System Science at Tianjin University. Her work focuses on atmospheric science, environmental studies, and climate change. In the April 2026 edition of Nature, she highlighted a trend she's been studying across 18 coastal cities around the world. Her research shows that as ocean temperatures have increased, the contrast between the land and the water during the day has become smaller. The water is still slower to heat than the land, but it's starting from a warmer baseline. So instead of a large temperature gap, you get a smaller one. And as that gap gets smaller, the pressure difference, the gradient, becomes weaker. And if the pressure difference is weaker, the wind that forms is weaker as well. That means a less noticeable sea breeze, or in some cases, a breeze that develops later in the day and doesn't move as far inland, or doesn't develop strongly at all. Her research suggests that in certain coastal regions, the strength of the breezes has decreased significantly over time, by as much as 45% in some cases. The study notes that the sea breeze hasn't disappeared completely, but it does indicate that the system is not behaving the same way as it used to. When you think back to everything we've talked about so far, you can understand why that matters. A weaker breeze means less cooling during the hot part of the day. It means less mixing of the air. That means more pollution, more pollen, more smoke that lingers longer near the surface. And it can affect rainfall. If that rising motion over the land is not as strong, or if the boundary between the sea breeze and the inland air is weaker, it can reduce the likelihood of afternoon clouds and storms forming in the same way. Indeed, between 1970 and 2010, her study indicated a significant decline in breeze days, afternoons characterized by cooling, inward-moving marine air, across several major cities. New York and Lisbon experienced decreases of over 30%, while London and Shanghai saw reductions exceeding 40%. But the pattern isn't the same everywhere. As you get closer to the equator, cities saw smaller changes. Mumbai and Miami, for instance, recorded minimal losses, around 3%, while Dubai and Jakarta saw a slight increase. Even so, the study suggests these regions remain at high risk. Without strong cooling breezes, they still face increased heat, higher humidity, and more intense weather driven by a warmer ocean temperature. It's still an active area of research. Scientists are still working to understand how widespread this trend is, how consistent it is from region to region, and how it interacts with other factors like urban development and larger-scale weather patterns. But the physics, it's pretty straightforward. If you reduce the temperature contrast, if you reduce that gradient, you reduce the pressure difference. And if you reduce the pressure difference, you reduce the wind. This is a good example of something we've talked about in other episodes. Climate change is not just about getting hotter. It's about how energy moves through the system. And in this case, it may be changing a pattern that many people have experienced without ever needing to think about the science behind it. So, what comes next? Well, this is where the conversation begins to develop, because scientists are still trying to identify these patterns. The next step is not to jump to conclusions. It's to continue to research, to continue to watch carefully, and to measure what happens next. Researchers are monitoring coastal cities around the world. They're looking at the temperature difference between the land and the water. They're tracking wind patterns. They're measuring how often these sea breezes develop day to day and how strong they are. They're also looking at how the changes connect to other parts of the Earth's system. Air quality is one of those connections. If breezes weaken, how often do we see stagnant air events? Do pollution levels stay elevated longer in coastal cities? Do pollen counts linger on calm days in the spring? How does this connect to human and ecosystem health? Rainfall is another. If sea breeze boundaries become weaker, does that change where storms form or how often they develop in the afternoon? As you can tell, there's a lot of questions here we still have to answer. These are slight changes in patterns that people have experienced for years, sometimes without realizing it. And that's where it connects back to you, the listener. You don't need a weather station in your backyard to start noticing these things. If you live near a coast, or even a large lake like the Great Lakes, you can pay attention to when that breeze arrives. Ask yourself, does it feel as strong as it used to? Does it arrive at the same time each day? Are there more days where it just doesn't seem to develop? If you've lived in the place for a long time, you probably have a baseline in your memory. You know what a typical summer afternoon feels like. And while one day, or even 1 year, doesn't tell a story, patterns over time can. And that's how science works. We observe, we measure, we look for consistency. And over time, those small observations begin to add up into something we can understand and then begin to talk about. Change only happens when we advocate for change. As we see changes like this develop, it's important to talk about this with your friends, with your family, with your elected leaders. Policy shifts are important, but when we talk about climate change and how it affects us personally, educating yourself and your friends and neighbors is just as important. Because climate change is not something that just shows up in averages or data. It shows up in patterns. It shows up day to day in the movement of air and the movement of energy. And sometimes it's a familiar breeze that doesn't quite feel the way it used to. One of the things that I do on this podcast is try to take something that seems familiar and help explain the science behind it. The land sea breeze is one of those things. It's a perfect example of how the climate system works. Small differences in temperature and pressure create movement in the atmosphere, and that shapes how we experience heat, air quality, even rainfall. And with research suggesting that local patterns may be shifting, it's more important than ever to monitor, to observe, and document those shifts. So the next time you find yourself near the coast on a hot afternoon, pay attention. Feel for that breeze. Notice when it arrives, and start to question what you experience in your everyday life. It's about recognizing the patterns around us and learning how to read what the atmosphere is telling us. I'm Dr. Mack, and this has been the Climate Translation. If you have a question about the climate you've been too afraid to ask, or if you have a differing opinion, please let me know. I can use your viewpoints in future episodes. You can reach me at theclimatetranslation@gmail.com. I'll see you next time.